So I want to talk about something called Squeeze Theorem. Some people call it the Sandwich Theorem. Okay, so let's take a look at a particular situation. Let's say I have a function like this. It's going to be, let's say, g of x. Let's say I have a function like this. Let's say this is f of x. And let's suppose I have a function like this. And let's say this is h of x. And of course, our best friend, little a. And hypothesis. Number one. First hypothesis. From the graph, would you agree that if I say near a, I have h of x sandwiched between f of x below and g of x above? Something like this. So this is above and this is below. Near a, I don't care what happens outside, but close to a, something like this. Do you agree with this? That function h is sandwiched or squeezed between lower function, which is f of x, and the upper function, which is g of x?
Yes.
Perfect. Second hypothesis, let's consider or assume that limit of f of x as x approaches a from either side is L. And also limit of g of x as x approaches a also exists, and it's L, which means this is a number. So I have here L. So now here's my final question. Can I write that from 1 and 2, comma, by the Squeeze Theorem, ST, by the Squeeze Theorem, limit of h of x as x approaches a is anyone?
L.
That's it. So, two things here. I have to show that near a, the function is squeezed or sandwiched. I also have to show that the limits of these two functions, the limits of these two, both exist and they are the same. If this is 5 and this is 10, I cannot conclude anything here. But the limits of these two functions, top and bottom, exist and they are the same number. If these two conditions or hypotheses of the Squeeze theorem are fulfilled, then it's guaranteed by the Squeeze theorem that the limit of h of x as x approaches a is L. Now the question is this. This is wonderful, a wonderful theorem. When will I use this? So what are you talking about here? Well, this happens in situations in which I cannot determine the limit by factoring, rationalizing, who knows what else. Adding, subtracting, who knows. So this is a situation in which I have no other way of finding the limit. So now let's take a look at a few examples. So I am, in other words, squeezed. I have no other way. I have to use theorem, the Squeeze theorem. Okay. 4, 5. I'm on page 5. So here is one example. And I'm taking it from the same page. I think it's 39 I was looking at. Yeah, here it is. So this is 39. And it says 4x minus 9 less than or equal to f of x less than or equal to x squared minus 4x plus 7. And for x greater than or equal to 0. And we are asked to find the limit as x approaches 4 from either side of f of x. Okay, so how will I ever apply anything else but the Squeeze theorem here? I don't even have, they're not even giving us the function. They're not telling us what the function is. So we had all these situations. We had the function, or the previous one, this one, we had the function. So we were thinking of different situations, like rationalizing the numerator. But here I'm not even given the function. But I am already given the first hypothesis of the Squeeze theorem. They're already telling me that this is the bottom function and this is the upper function. So the function that I don't even have is already squeezed between two functions. So this is already the first hypothesis of the Squeeze theorem. All I need to do is check the second hypothesis. What is the second hypothesis all about? What do I need to determine?
That the limits of the two functions are the same.
When x approaches
4.
Excellent. From 4x, who was that? Caitlin, thank you. And the limit as x approaches 4 from the other one. Of course these exist. Why? What functions are these?
Linear and quadratic.
A polynomial in general. Excellent. Perfect. Linear and quadratic. We call them polynomial. Excellent. So of course the limits would exist. But now the question is if they are the same. Because if they're not the same, then I cannot find this limit. And I cannot use the Squeeze theorem. The Squeeze theorem has two hypotheses. Both of them have to be fulfilled. So then, can anyone give us the answer there?
Seven.
Good. So 4 times 4 is 16, 7. And what about for this one? 16 minus 16, 0, 7. Good. So now from 1, we don't even have the function notice again. From 1 and 2, by the Squeeze theorem, what do we conclude about the limit as x approaches 4 from either side from f of x that we don't even have?
Equals 7.
Indeed, by the Squeeze theorem. I would like us to look at one more example. Let's say 41. So the limit as x approaches 0 from x to the 4th times cosine 2 over x. So the first thing I have to do when I'm asked to find the limit, again, this is always the case. I know I will be sounding like a broken record the entire semester. Sorry about that, but it's the only way that I know of. Repeating, repeating, repeating. So what do I have to do? First step here.
Plug 0 in.
Good. So I have, when I plug the 0 in here, this does not exist. And this approaches 0. You can say 0 times d and e must be 0. No, no, no. So this is a specific situation in which my only chance, my only hope is the Squeeze theorem. That's my only hope. But remember, the Squeeze theorem has how many hypotheses? Anyone? How many hypotheses? Does
2.
this 2. So in the first one, I have to show the sandwich or the squeeze. I have to show the squeeze. How do I show the squeeze? meaning I have to find the bound functions, right? I have to find, so if this is my function, I have to find the upper function and the lower function near this. I don't care outside, but close to it. So I have to show that, to find the top and the bottom. Okay. So I don't know much about x to the fourth, but I do know something very important about cosine. So do we know anything about cosine? And we're talking about bonds, boundaries. So do we know anything about cosine? Any cosine? And here's your hint. For any cosine of any angle.
Zero at 2 pi, right?
Values of cosine. What is the smallest possible value for cosine? What is the largest possible value for cosine?
-1 to 1.
Very good, thank you. -1 and 1. Have I found the squeeze? Not yet. I only found the squeeze for this piece. But I need inside, in the middle part, I need to have x to the fourth. So what should I do to all three sides of this compound inequality to get my function in the middle? I have part of it. I don't have everything. So what should I do to all three sides to have my function in the middle?
Multiply by x to the fourth.
Absolutely. But I have to analyze this for a moment. This quantity has to be strictly greater than 0. If it isn't strictly greater than 0, then I have to switch the inequality symbol. And I don't know when. If it is 0, then I'm in big trouble. I cannot multiply by 0. I'm not allowed to multiply by 0. So I can do this only if this quantity is strictly greater than 0. Is, first of all, this quantity always positive?
Yes.
Always, because it's power 4. Can it be 0? The answer is yes. But I'll absolutely have to say no, because this means x approaches 0 and it does not equal 0. We know that. So this is a legitimate operation. We always have to ask ourselves, is this legitimate? Don't just go ahead and do it. It's legitimate. It's not 0 and it's always positive. I don't have to worry about the inequality symbols. So I have negative x to the fourth less than or equal to x to the fourth times cosine 2 over x less than or equal to x to the fourth. So now the squeeze is complete. I found the low bound and I found the upper bound. Or maybe I should write lower and upper. So the squeeze is done. Now I need number 2. What is number 2?
Limit has to be the same.
Limit of?
The lower and upper. No.
Very good. When x approaches
4, or as x approaches 0.
Excellent.
Right.
So this is, and the limit of x to the fourth when x approaches 0, and this is. Awesome.
Zero.
Excellent. So then I will have to write this last sentence. Everything has to be presented like this, step by step, everything. So from 1 and 2, by the Squeeze theorem, we concluded the limit of x to the fourth cosine 2 over x as x approaches 0. And you can say, see, I told you. You're going to get 0 from the beginning. No, 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 no. So what is this limit then? By the Squeeze Theorem?
0.
0 indeed. Great job. Great job. So as you notice, for a second I want to say one thing. As you notice, we're getting into step-by-step more complicated stuff. Please, I've gotten in the last years very good at begging. So I'm begging you, and I don't mind begging you. If it helps, I will do it. Please rewatch the steps. Please watch the video again and do the problems again. And only then say, I got it now. And work on a problem with the answers in the back or whatever you want to choose. So please, I'm begging you. Because it's going to accumulate and the information becomes, and very soon our head will explode because it's a lot. So please do that for me, please. Okay, I just want to show, and I want you to choose any problem you want from these. We have to work on at least one problem with absolute value, and then we can move on. That's very important. At least one, please. And 46. Then we can move on. Which one did we pick?
46.
46. Okay, let me copy 46. Where is it? Okay, so limit as x approaches -2, 2 minus the absolute value of x, 2 plus x. Perfect. Okay, good pick. So let me see how I'm doing with this video.